Hello, this is Bobby at Copel TV Repair with a functionality proof and an quick instructional video on how to test power supply board 40-P402WL-PWB1CG, which is used in a number of TCL, I believe 75-inch monitors. It will be in the title in the video. This video, as I said, will be both functionality proof for the customer who ordered that board, and today is August 19th, and this is a unique marking and possibly another unique marking somewhere, and also instructional video for everyone else. Yeah, those are fairly unique here. This will show that this is the board. Now, this is an LED board, but unlike most of the modern LED drivers, this one does not have LED power boards. This one does not have a built-in driver for the LEDs. It has those connectors, and to find out what they do and how they do it, you gotta take a look. Oh, that's another fairly unique marking on the board. But to see what those connectors do, you want to turn to the back and look at them, and the first one that you want to look at is the small one with 2 rows, and the legend about what its pinout is up there. Really quickly, what's interesting for that on that board is it's 24 volts at 4 amps, and this is the standby power. This is what comes out of the board, readily available, and goes to the main board. For most boards, this would be 5 volts or 3.3 in some Sony and other boards. But there is also a class of TVs that simply take higher voltage, and this is pretty popular trend with recent TVs. They just take one high voltage, and internally the main board breaks it down in many lower voltages. So this output here, the standby, the drawback of this approach is that you have efficiency basically, and in standby mode you normally have higher consumption in order just to secure higher voltage. It pulls more from the power, but apparently those guys don't worry about that. So they produce 24 volts, and without nothing connected to that board, there should be 24 volts on those 3 pins that are marked at the bottom 2. And the one above, the one on the right, which is again this. Come on, focus. This, and that. And as you can see, they're all on the same track. And this is what this here, the bottom 2 and the one above it. So 24 volts to ground, and this would be the ground, and it would also be the second pin on the left side, this one. And this will also be the bottom 2 pins. This will be the ground. So between those, you will be having 24 volts. Nothing else will be there on the other connectors. I will go to them in a moment, until the pin that is marked as PS on, and that would be this pin, which comes to here and goes back. Until that happens, it will not do anything. I will pause here a second and continue right away. Okay, back to recording. So some voltage needs to be supplied here, and on boards that have 3.3 or 5 volts standby output, you normally return back the same 3.3 or 5 volts or anywhere in the range. Actually would be a logical one in the TTL world, and usually it's pretty safe to just apply 3 volts or 4 volts or even 5. Some people jump it through a resistor that is 1K. Some jump it directly with a wire, but there are some boards that are a little bit trickier than that. I will get to that in a minute. Now, when that is jumped, the board wakes up, and one of the things that happens is the power factor correction circuit that's on that part of the board raises the rectified voltage, AC voltage, that comes into the main outlet, and from 160, 170 volts raises it to nearly 400 volts on those 2 capacitors. So when the board is activated, you should be able to measure 400 here or here where they are at the back marked as capacitor and capacitor. And this is how you know the PFC works. And after that happens, another part of the board activates, which drives those two transformers, and they in turn, this is the driver for them, and they in turn make it so that output voltage marked as VIL LED goes on those two connectors. They're in parallel, so whatever gets here gets here. And there is a number of other identifiers here, like 3D enable, backlight on, pulse dimming, analog dimming. You should know that those, in many boards, like in this one, are just jumpers. They transfer signal from here to here, but they don't actually go back further into the board. So to find out what output voltage you will be getting, that is for the LEDs, you look at those capacitors and they tell you that they have a breakdown voltage of, come on, show me, what is your breakdown voltage? Okay, it's such an angle, there it is. Okay, you see that they are 1500 microfarads at 25 volts. So that means the highest voltage that's going to come out here is going to be possibly 24, but it shouldn't be 24. It should be less than that, because in that case the capacitor should be 35 volts. If they are rated 25 and the board is properly designed, I would expect that the output voltage here is 12 volts. So how to test it, I'm going to get back to this connector in a second. Still recording. Supplying AC power, it's extremely inconvenient here because it wants it that way. And there you go. Getting this voltmeter up. And we'll be measuring the standby. The procedure for testing the board is not much different than many other power boards. And maybe I shouldn't be taking so much time, but as I said, now that it is connected, our attention is here and we want to see what is the output voltage. One simple way to do it actually is to get it over the electrolytic capacitors that are here on the board next to the connector, and as you can see, it is 24 volts as it should be. Now to activate the board, as I said, you gotta supply some voltage here on the PS zone, and one of the reasons for making that video is when the output standby voltage is so high, the boards can have a different voltage on which they respond. You can try jumping 24 directly, which would be getting the 24 here and jumping them here, and if you do so, I know somebody will come and say that that's the wrong way to do it, but you can do it, and many times there is no penalty. Usually there is no penalty for it, and one way to tell basically is to check whether the PS zone goes to a resistor, and it does, which is a fairly high value. And it is, and of course we do check that, and of course we did it the other way, but what I'm trying to say is that if you jump it, you will find fluctuating voltage here at the output. It's not going to do anything the way it should. And if you pass, let's say, 4 volts here, and you can do that by a simple voltage splitter, you might find that it's not activating. So what I ended up doing is using a little board, voltage regulator board, that you can buy on eBay for, you know, a couple of bucks. It is based on LM20, come on, the board is working there. It is based on LM2596, and if you just search for LM2596, you're going to find something like that. I just hacked a little connector that takes me the 24 volts and feeds them in the input of that board, and at the output of the board I am feeding the PS-on signal. This is a little pot that allows me to regulate the output voltage, and I just turned it until the board started responding and started producing voltage here. It was around 9 volts, so oddly enough that board is being activated somewhere around 9, possibly 10, I'm sure 10 will work. And this is where I left it. I also, if you do that, you will start getting fluctuating, turning on and off voltage here that varies between 8 and 9 volts. And I'm not going to show you that, but instead tell you something different. It will continue fluctuating until you put a load on the standby 24 volts here. That load in this case is a little resistor. This one is like 120 ohms because that's what I had. And it does warm up. Maybe twice the value would do a better job. But if I put that on, the output voltage will be produced and stable. See that? This is the output voltage, 1274. And that resistor will start smoking probably soon. This is where am I? And this is the 20. Sorry, not holding it well. This is the way, and those are pretty much the only two voltages that this board holds. The 24 here and the 12 here. But the 12 will not appear until you have that load on the primary side, on the standby output voltage, that will stabilize it. And this is what's crucial for that board. And that's all. The rest again are signals that are just passed from one connector to the other, with the exception of one, which is protection, which blocks the whole thing. It's marked PT here. And that's it. That board, well, to be 100% compliant, we need to measure that it really can hold 4 amps. And whatever, it doesn't say anything anywhere around the board, what power does it need to be able to provide for the 12 here. But it is extremely rare that they don't hold voltage well. So this is it. Just to know that it tests, that it works and produces the output voltages, you do need to make a little exercise. Again, number one, remember the voltage that you activate it with. I wouldn't be surprised if passing 24 directly works, but it does need more than 5 to jump out. It needs about 10. And number two, load the standby 24 in order for it to hold. That's all. Best of luck. Thank you.